Hi there, welcome to my office. Today we're going to be talking about a very important aspect of robot design, drivetrains. A drivetrain is a system of wheels, motors, axles, chains, and other components that helps your robot move. Drivetrains are important not only in making sure your robot can move, but in making it move the way you want it to, and making sure it can move for the entire match. Today we'll be learning how to plan, design, and build your very own drivetrain.
There are many different styles of drivetrains. Before you can building your drivetrain, it is important to have an idea of what you want and what you need it to do. The decision of which drivetrain you want can be made using the engineering design process. Constraints such as materials available, robot size, and the strength of the motors used should all be considered in this decision. Now for the fun part, the math.
Once you've decided what kind of drivetrain you want to build, you need to design it in such a way that it can do everything you want it to. To accomplish this, you're going to need to familiarize yourself with the gear ratio equation, shown here. This equation states that the gear ratio of a system is equal to the diameter of the output gear over the diameter of the input gear, which is also equal to the number of teeth of the output gear over the number of teeth of the input gear, which is also equal to the angular velocity of the input gear over the angular velocity of the output gear, which is finally equal to the torque of the output gear over the torque of the input gear. Now, there are a lot of relationships established here, but the one we're going to look at is this one right here between angular velocity and torque. Angular velocity is expressed with lowercase omega and measured in RPMs. Torque here is represented by tau. Now these two are inversely proportional, which means as a designer you're going to have to make a trade-off. This trade-off is going to be between the speed of your robot and the power that it has when pushing. Now, that is up to the builder. And speaking of building, that's what we got next for you.
Now for the actual fun part, building stuff.
Knowing about torque and gear ratios is all well and good, but what really matters in the arena is how your robot performs.
That's right, Ethan. What we want to do is outpace every other robot on the field.
To do this, we have two very large gears driving a really small one.
Before you go, there are a few tricks about building drivetrains that you should know, which are included on our robot, Heisenberg.
These tricks are using a chain to drive two distant gears and putting two gears on the same axle, like this.
Using a drivetrain to drive distant gears gives you much more control over being able to turn. The trick with multiple gears allows you to speed up big gears to provide both speed and power.
You should note that these mock-ups were quickly built and are meant to prove a concept. If you actually want to include these components on your robot, you're going to have to design them to be much sturdier than these here. Now to review. Today we learned how to use the engineering design process to pick what kind of drivetrain you want. We learned how to use the gear ratio equation to design it in such a way that it can do everything you want. And we learned a few quick tips and tricks on how to build it.
That's all we have for you today. Thanks for watching.